Hello everyone, I'm Yogesh Guge and along with my teammates Banait Vaibhav and Pagar Hemant, we are here to represent our final project IoT-based home automation system. We are from SNJB KVG College of Engineering, Sandwad. This project was developed as a part of our IoT internship batch B5 at Emertxe. Internship overview. Our internship focused on the Internet of Things or IoT. The goal was to understand how IoT can make our daily lives smarter through automation and data driven systems. We began by learning programming in C and C, then explore embedded system and finally implemented our IoT project. Through this project, through this internship, we gain hands-on experience on connecting hardware and software using Arduino IDE, Pixim Lab Simulator, and Blink IoT cloud platform. This project was not only strengthen our technical knowledge but also improve our creativity and problem solving abilities. What I learned from the internship. During this internship, I learned about the complete architecture of IoT, include how devices gateway and cloud platforms communicate. We work with sensors, actuators, and microcontrollers to build functional IoT prototypes. I also developed programming skills in C and C, and I also developed programming knowledge, learn and how data is collected and transmitted through protocols like MQTT and HTTP. One key takeaway was understanding how to integrate IoT devices with cloud platforms for real-time monitoring and control. Finally, we applied all those skills to build a complete IoT-based home automation system. Next, we will see C programming. In the early phase, we focused on C programming. We received the basic like variables, loops, arrays, and functions. Then we moved to advanced concepts such as pointers, structures, and dynamic memory allocation. This helped us understanding how embedded C interacts with hardware components in real time. We also learned techniques to ensure our code was efficient, modular, and reliable. This knowledge became the foundation for writing code that controls sensors and actuators in IoT systems. C++ programming. Next, we explored C++ programming, which included which introduced us to object-oriented concepts like classes, object inheritance, and polymorphism. Using C++, we learn how to design modular and reusable IoT applications. We also practiced using pointers and file handling for hardware level interaction. C++ helped us to structure our code efficiently while improving performance and reliability. This made it earlier to integrate microcontroller and sensors for real-time operations in our project. Embedded system. Then we move to embedded system. An embedded system is a specialized computer designed to perform a specific function within a larger device. It combines both hardware like sensors, actuators, and microcontrollers, and software which we program in C and C. Embedded systems are used in everywhere in home appliances, home automobiles, medical equipments, and industrial machines. They are compact, reliable, and power efficient, forming, and forming the backbone of IoT devices. In our case, the Arduino Uno acted as the core embedded system controlling the sensors and devices. System overview. Our system consists of several components. First one is the Arduino Uno act as the main controller. Second one, the LDR sensor detects light intensity for garden lighting. A temperature sensor monitoring room temperature for heater or cooler control. A water tank level sensor tracks the level in a storage tank. The Blink IoT cloud stores and updates real-time data. And the Blink IoT mobile app allows remote control and monitoring. Together, these components form a smart home automation network. Project implemented. That we are in this internship, we implemented three key automation projects. First one, garden light control system. Second one, temperature control system. Third one, water control tank control system. Each of these projects demonstrate how IoT can automate daily households activities, conserves energy, and reduces manual efforts. The first one is garden light control. The garden light control project is uses an LDR sensor to detect ambient light. When it gets dark, the lights automatically turns on, and when it's bright, they turn off, saving energy. The Arduino microcontroller reads the sensor data and switches the lights using relay module. This project shows how simple automation can make outdoor lighting more efficient and eco-friendly. Second one is temperature control. Our second project is temperature control. We use an LM35 sensor to continuously monitor the room temperature. If the temperature exceeds a set limit, the Arduino automatically switches on a cooler or heater. Once the temperature stabilizes, the device turns off. The data is also sent to the Blink app where users can monitor real-time temperature remotely. This system enhances comfort and reduces electricity consumption by automating climate control. Third one is water tank control. The third project is water tank control system. It uses ultrasonic or water level sensors to detect the tank's water level. When the water drops below a minimum threshold, the pump automatically turns on. Where the tank is full, it switches off to prevent overflow. Real-time data is displayed on Blink app, allowing the user monitor water levels from anywhere. This project promotes efficient water use and prevents wastage. To conclude our project, to conclude our project, home automation system demonstrate how IoT and embedded systems can make everyday tasks smarter and more efficient. This internship gave us valuable hands-on experience in sensors, microcontrollers, cloud integration, and programming. We are thankful to our mentors and Emertxe team for the guidance through this internship. Thank you for listening.
Hello everyone, my name is Hemant Pagar and I am currently pursuing my IoT internship at Emertxe. In this project, I will be explaining my IoT based home automation system titled Home Automation System using Blink IoT app. The main aim of this project is to monitor and control home appliances remotely using the Blink IoT platform. Through this project, I learned how to interface sensors and actuators with Arduino and how to connect them to the cloud for real time monitoring and control. Let's first understand what this project does. This system allows a user to control the brightness of a light using an LDR module, monitor the temperature using a temperature sensor, and they measure the water level in a tank using a serial tank. All this data is displayed on both on LCD and the Blink mobile app. So the user can control and monitor the home environment from anywhere in the world. The hardware components used in this project are Arduino Uno, which act as the main microcontroller, LM35 temperature sensor, LDR sensor module, serial tank, 65 to LCD or switches and an Ethernet module. On the software side, I have used Arduino IDE for coding and uploading the program, the Blink app for the user interface, and the Blink Cloud for data communication between the app and Arduino. Now let's move to the code explanation part. This project code is written in C++ using Arduino libraries. It is divided into different sections for clarity and modularity. At the top, the code includes header files like SPI.h, Ethernet.h, Blink Simple Ethernet.h, Wire.h, Liquid Crystal I2C.h. These libraries help in either Ethernet communication, I2C LCD display, and Blink connectivity. It also includes custom headers files like LDR.h, main.h, temperature system.h, and serial tank.h. Each of these files handles specific sensor functions, for example, LDR, temperature, and tank monitoring. Next, we have the Blink authentication token, template ID, and device name. This this is the template ID. This is my template name, and this is the Blink authentication token. These are the unique identifiers that link our Arduino device to the specific project on Blink Cloud. Without these, our Arduino cannot communicate with the Blink app. The next section includes Blink write functions. These are callback functions that are automatically executed whenever but button function is pressed in the Blink app. When the user turns on the cooler in the app, the function is triggered. It updates the cooler status on the LCD display and physically switches the cooler on or off. Then heater virtual pin. It control it turns the heater on or off based on the app command and update the LCD with the heater on or off. The inlet and outlet valves are also controlled through virtual pins like inlet virtual pin and outlet virtual pin. They allow the user to control the water flow into or out of the tank directly from the mobile app. Then update temperature reading. It is responsible for continuously sending sensor reading to the Blink app using Blink virtual write function. It sends the temperature reading to the temperature gauge and water level volume to a water level gauge. If the template the To make the system smarter, two automatic control features are implemented. First is it handle temperature. If the temperature is goes above 35 degrees Celsius, the heater will turn off automatically to prevent overheating. Second, handle tank. If the water level in a tank goes below the 2000 liters, the inlet valve turns on automatically to refill the tank. These automation features make the system intelligent and self-regulating. The loop function keeps the system running continuously. It performs these actions repeatedly, runs the blink communication, executes the timer for a specific periodic updates, reads the LDR sensor to adjust light brightness, handles temperature and the tank logic, and display on the LCD. For example, LCD shows temperature is equal to 28 degrees Celsius and water 2144 liter, and the system update in a real time. This is the code. This is the code we have implemented for the our project smart home automation system to control LDR, to control light using an LDR, the temperature and the water level. The next comes to the simulation of this project. For this we have to upload our code in Pixim Lab simulator. For this we have to load X file. In this simulation, Pixim Lab responds late. Therefore, the Pixim Lab not work smoothly. The Pixim Lab shows the output sometime late. In a blink app, we created heater button, cooler button, and temperature gauge for to control the temperature, temperature, and inlet valve, outlet valve switch, and volume of water level. The home automation is printed. Then the as we decreases the resistance, the light will turns off, and as we increases the resistance of a LDR, the light will glows. Same as when we on heater, the LCD shows heater is on, and the temperature is when we off the heater, it shows heater is off. Then we on when on the cooler, it shows the cooler is on and reduces the temperature to to the normal temperature. When we on inlet valve switch, then the water enters into the tank from inlet valve and it shows inlet flow is on like this. When we off the inlet flow, it it shows the inlet flow is off, outlet flow is on. Then the issue then the flow of water is towards the outlet valve. Outlet flow is on. Inlet flow is on. In this way, we have completed our project. From this IoT internship project, I have learned to interface multiple sensors with Arduino, use Blink cloud for IoT communication, implement real-time monitoring and control, and design safe and automated system using conditional logic. This project gave me a strong understanding of IoT architecture, including hardware, cloud, and mobile app integration. In conclusion, this home automation system using Blink project demonstrate how IoT can make our homes smarter, safer, and more efficient. It's a great example of how embedded system and IoT can work together to create real-world solutions. Thank you for watching my project demonstration, and thank you to Emertxe for providing such a valuable internship experience where I got explore practical IoT applications.